What if the universe could end instantly, without any warning? No countdown, no final moments, just gone. This isn't the plot of a science fiction movie. It's a genuine scientific theory known as vacuum decay, and it describes what could be the most terrifying, yet fascinating, end imaginable for our cosmos. To understand it, we need to dive into the strange world of quantum physics. Imagine the empty space all around us. We think of it as nothing, a true void. But according to quantum field theory, it's not empty at all. It's a seething, dynamic field of energy, a quantum field, and the most important one for this story is the Higgs field. This field permeates the entire universe, and its existence is what gives fundamental particles their mass. You, me, the Earth, the stars, everything owes its substance to the Higgs field. The laws of physics, as we know them, depend on the properties of this field. Think of it like the operating system for the universe. For our universe to be stable, the Higgs field needs to be in its lowest possible energy state, what physicists call the true vacuum. It's like a ball resting at the very bottom of a deep valley. It's stable, secure, and has nowhere else to go. But what if our universe isn't in that state? What if we're in what's called a false vacuum? Picture that same valley, but now imagine a smaller, shallower dip high up on the slope. If the ball is resting in that smaller dip, it feels stable. A little nudge one way or another, and it just rolls back to the center of the dip. It seems safe. This is the false vacuum state. From inside this little dip, everything looks normal. The laws of physics work, stars shine, and life evolves. But there's a catch. The true deeper valley, the true vacuum state of lower energy, still exists. There's a barrier of energy, a hill, separating our false vacuum from the true one. For a long time, everything could be fine, but quantum mechanics has a strange rule: quantum tunneling. Even without enough energy to be pushed over the hill, there's a tiny, non-zero chance that a particle could suddenly appear on the other side. It could tunnel right through the energy barrier. If this were to happen to the Higgs field, even in just one single point in the entire universe, it would be catastrophic. A tiny bubble of the true vacuum would spontaneously come into existence. Inside this bubble, the fundamental nature of reality would be different. The Higgs field would have a different value, which means the masses of fundamental particles like electrons and quarks would change. The consequences would be immediate and absolute. The very rules of chemistry and physics as we know them would break down. Atoms could no longer hold together. The structures they form, stars, planets, life itself, would instantly disintegrate into a soup of elementary particles. But it wouldn't stop there. This bubble of new physics, this true vacuum, would be in a more stable, lower energy state. And like a hole in a dam, it would immediately start to expand. And here's the truly terrifying part. This expansion wouldn't be slow. It would happen at the speed of light. Because nothing can travel faster than light, including information, we would have absolutely no warning. There would be no distant flash in the sky, no message from astronomers about an approaching doom. One moment, the Earth is here, orbiting the sun, and you're watching this video. The next, the bubble of true vacuum arrives, and in an instant, the Earth, the sun, our entire solar system would be gone, converted into a fundamentally different state of reality. As this bubble of destruction expands at light speed, it would be an unstoppable wave, consuming everything in its path. Galaxy after galaxy would be wiped from existence, their light and matter rewritten by the new laws of physics inside the bubble. The entire cosmic web, the grand structure of the universe that has taken billions of years to form, would be erased as the bubble continued its relentless expansion, eventually engulfing the entire cosmos. The universe as we know it would cease to be, replaced by a new universe with different physical constants. It might be a dead, empty place, or it might be something so alien we can't even conceive of it. So, how likely is this? Well, based on our current measurements of the Higgs boson and other particles, it seems our universe is indeed in one of these metastable or false vacuum states. But the good news is that the energy barrier between our vacuum and the true vacuum appears to be incredibly large. The probability of a tunneling event happening is so astronomically small that the calculated lifetime of our universe is many, many billions of times longer than its current age. The universe will likely end from heat death, the slow fizzle of all stars, long before it gets a chance to pop. Still, the possibility, however remote, hangs over our existence. It's a profound reminder of the cosmos's delicate nature. We live our lives on a tiny planet under a set of physical laws that feel permanent and unchangeable. But the theory of vacuum decay suggests that our entire reality might just be a temporary phase, a cosmic accident, waiting for a quantum fluctuation to correct it. It reveals that the universe may be far more fragile than we ever imagined. It forces us to confront a reality where the end isn't a gradual process, but an instantaneous, silent event that could happen at any moment, anywhere in the vast expanse of space. So the next time you look up at the night sky, remember the invisible quantum field that holds it all together and the tiny ever-present possibility that it could all change in the blink of an eye. Thanks for joining me on this journey to the potential end of everything. If you found this as mind-bending as I do, be sure to like this video and subscribe for more explorations into the deepest mysteries of our cosmos. See you in the next one.